For some context, AP Calculus BC basically covers the first two college calculus courses, Calc 1 and Calc 2. AP Calculus BC contains 10 units in total, which is 2 more than Calc AB. Anyways, I got a 5 in AP Calc BC this year, and I'm going to show you how you can get a 5 as well. In this video, I'll be going over all 10 units in Calc BC and help you guys get a 5 as well. Unit 1 is called Limits and Continuity. In this unit, it's basically like an introduction to calculus. It introduces the idea and concept of instantaneous rates of change, which, spoiler alert, is just called the derivative. You're also taught to estimate limits using graphs and tables, and also value limits using factoring and algebraic identities. There's also many different theorems, for example, the squeeze theorem, which determines the limit via trapping it between two others. Another major topic in Unit 1 is the different types of discontinuities. For example, there's the removable discontinuity, the jump, and infinite discontinuities. And you're also taught to check whether a function is continuous at one point via many different tests. You're also taught about infinite limits and vertical asymptotes and limits as they reach infinity. And this unit ends off by teaching you the intermediate value theorem, which is a theorem that states that a continuous function takes every value between two outputs. Second unit, Unit 2, is called Differentiation. So the first part of this unit just introduces average versus instantaneous rate of changes, where you compare the average slope to instantaneous slope. You also learn the definition of a derivative using limits. You also learn to estimate the derivatives via looking at the graph using the slopes. And you also learn where the derivatives exist and they don't. You're also taught the power rule, which is an easy way to differentiate polynomials and other basic derivative rules. And you're also learned the derivatives of common functions such as e to the x, sine x, cosine x. And you also learn the basic rules, product rule, quotient rule. And this unit ends off by introducing the remaining trig derivatives such as secant, cotangent, and cosecant. And the next unit, Unit 3, is called Composite, Implicit, and Inverse Functions. So this unit starts off by introducing the chain rule, which is a way to differentiate functions that are inside other functions. It also introduces implicit differentiation, which differentiates equations without solving for a y. You're also introduced to inverse functions and inverse trig functions and their formula. And the unit ends off by introducing higher order derivatives such as the second, third, and even higher derivatives. Now Unit 4 is about contextual applications. So first it starts with the definition of derivatives and their real-world appliances. It talks about motion used in physics such as relative position, velocity, and acceleration. It talks about the rate of change where you apply derivatives outside of motion problems, and also related rates where you use derivatives to set up equations involving multiple changing variables. Most related rates problem will use implicit differentiation to solve, and you'll also learn linearization, which is how to approximate functions using tangent lines such as the slope. And the unit ends off by introducing L'Hopital's rule, which is a way to evaluate indeterminate limits, such as limits that go to 0 over 0 or infinity over infinity. And now Unit 5, which is called Analytical Applications of Derivatives. So the unit starts off with introducing the MVT and the EVT. So the MVT, the mean value theorem, just talks about how you can relate average and instantaneous rate of changes, while the EVT, extreme value theorem, just helps you find the absolute and local extrema. You're also taught how to analyze graphs just by looking at the first derivatives. And you're introduced to the first and second derivative tests, which can both help you find the maxima and minima, and also help you find the concavity of graphs. You're then taught how to graph the function just by analyzing the derivative information, and you also learn to connect the first, second, third derivatives of a function. And you also learn optimization in this problem, where you use calculus, specifically derivatives, to optimize. And this unit concludes by teaching you implicit relations and how to solve them. And now Unit 6, which is called Integration and Accumulation. So this unit, it introduces accumulations of change, where you just add tiny little changes to find the total change. And you're introduced to Riemann sums, which are basically ways where you could approximate the area under a graph via rectangles. You're then introduced to probably the biggest topic in calculus, which is integrals. So you're taught about definite integrals, which can represent an exact accumulated area. You're also introduced the fundamental theorem calculus, which just states that the integral of a derivative is basically itself. And you're also introduced to properties of definite functions. And now via the fundamental theorem calculus, we can learn that the integral is essentially the antiderivative. And you could basically solve the integral of basic polynomials using the opposite of the power rule. And you're also introduced to other integration methods such as U substitution and integration by parts, which are pretty important. You're then taught partial fractions and also improper integrals, which are basically integrals with infinity as their bounds. And it ends off the unit by just teaching you about the different techniques and choosing the best integration methods to solve the problem. And the next unit is Unit 7, which is differential equations. The start of this unit includes just building differential equations from real-world situations to solve real-world problems. The unit then goes on to teach you about slope fields, which is basically a way to sketch solution behavior without actually solving it. And you're also taught to analyze the slope fields by looking at it. Then you're introduced to Euler's method, which is basically a method that uses derivatives to approximate solutions. You're then introduced to more methods to solve equations, such as separation of variables and also using initial conditions to solve it. And the unit ends off by introducing exponential models and logistic models, which model growth and decay with a carrying capacity. And now Unit 8, which is called Applications of Integration. This unit starts off by introducing average value, which is a way where you can find the average value of a function over an interval. And you also learn about motion from integrals, where you could find out the position, velocity, and acceleration via integration methods. You're also taught how to find the area between two curves and multiple intersections, which in that case you have to split up the integrals into two or more to solve. The idea of cross-sections are also introduced, where via the cross-section shape, such as squares, rectangles, triangles, or semicircles, you can use that information to find the volumes of the rest of the solid. You're then taught the disk method, which is an integration method to find volume by revolving around a region with no hole. And you're also taught to use it on other axes as well. And the next part introduces the washer method, which is similar to the disk method, except a hole is present in the middle. Then you're also similarly taught to use the washer method around different axes as well. And the unit concludes by teaching you about arc length and how to compute the arc length over a smooth curve. Next is Unit 9, which is one of the BC only units, and it introduces parametric, polar, and vector functions. So the unit starts off by introducing parametric equations, which are basically curves that are defined by two different equations, and also learning to take the derivative of them. You're then introduced to second parametric derivatives, which is basically taking the second derivative of parametric equations. You're then taught about parametric arc length, which is a method used to calculate the arc length of a parametric curve. Next, you're introduced to vector-valued functions, and you have to differentiate vectors as well. Then it teaches you about integrating vectors and integrating them component-wise. And next, it talks about motion with vectors, where you can find the velocity, acceleration, and speed of vectors. You're then introduced to polar coordinates and learning to differentiate them in polar form. And you learn to calculate the area of polar equations, which are basically the area enclosed by one polar curve, and also the polar area of two curves, which is basically the area that has been enclosed by two different polar curves. And now the final unit, Unit 10, which is also a BC topic, is on infinite series. It first starts off by talking about convergence and divergence, which determines if an infinite series has a sum or just diverges to like an infinite number. It also talks about geometric series, which have a common ratio, and it talks about the different tests that can be applied to find if it converges or diverges. The first test that's introduced is the nth term test, which check whether a series diverges or not. The next test introduced is the integral test, which just takes the integral of the series to see if it diverges or not. The next test is the harmonic or p-series test, which recognizes common convergent and divergent series to see. The next test is the comparison test, which compares series that already converge or diverge to an unknown series to decide if the unknown series converges or diverges. And the next test is the alternating series test, which tests the convergence of alternating series. You're then introduced to the ratio and the root test, which are another way to calculate if the series converges or diverges. You're then taught about the concept of absolute versus conditional convergence, where absolute convergence is basically if the series is taken, its absolute value, is it still convergent or not. You're then taught about error bounds to see what the maximum value of error can be for estimation. Next, you're introduced to Taylor polynomials, which are basically ways to approximate functions using finite polynomials. And Taylor series are a type of power series. And a power series is basically a series in which the coefficient changes each time alongside its power. You're then introduced to Maclaurin series, which are a very similar cousin of the Taylor series. And next, you're going to be introduced to the Lagrange error bounds, which some say is the hardest topic. But it's basically a way to approximate the error in Taylor and Maclaurin series. And that's pretty much the end of Calc BC. There's a lot of topics I missed simply because the video would take too long. But if you have any questions, please leave them in the comments and I'll try my best to address them. Thank you guys.